Good morning, all. I'm going to take a lecture about circular pre-stressing. My name is Abhinandan. I'm an VAT student. Okay, we can cover the topics around the introduction of circular pre-stressing, general analysis and design. We can see about pre-stressed concrete pipes, ring beams, and then we can conclude. We can see the design analysis part in this pre-stressed concrete pipes and the ring beams. First of all, you can see what is circular pre-stressing. And the pre-stressed member are curved in the direction of pre-stressing. The pre-stressing is called circular pre-stressing. For an example, uh, uh, the circumferential pre-stressing in the pipes, tanks, silos containing structures or similar structures uh, are types of circular pre-stressing. In these structures, there can be pre-stressing in longitudinal direction as well. It can have pre-stressing in longitudinal direction also. In circular pre-stressing is applied on the dooms and the shells. They act upon the dooms and shells. The circumferential pre-stressing resists the hoop tension generated due to internal pressure. The pre-stressing is done by wires and tendons placed spirally or over sectors of the circumferential of the member. The wires of or tendon lay outside the concrete core. The pre-stressing is done by the wires or tendons placed over the circumferential of the member. Hence, the center of pre-stressing CGS, pre-stressing steel CGS is outside the core of concrete section. The hoop compression stress is generally considered to be a uniform across the thickness of the thin shell. Hence, the pressure line lies at the center of the core of the concrete. We can see here in this diagram where the center of the gravity lies of concrete here and then steel here. This is due to the pre-stress. Due to the internal pressure, we have the P. These are the following sketches shown in the internal forces under service conditions. The analysis is done for a slice of unit length along the longitudinal direction. We can do this in the along the longitudinal direction, where we can find the pre-stress. There will be there will be a pre-stress when we design this. To avoid those pre-stress, we can use buttress. These are used to reduce the loss of pre-stress due to friction. The pre-stressing can be done over sectors of circumference. Buttress are used for anchorages of tendons. These are the following buttress. Okay. Next, we can go for the general analysis and design of pre-stress, circular pre-stressing, where we have the components of compressive stress, FC. First, compressive stress can be calculated from the compression C, which is equilibrium. From the equilibrium, C is equal to P naught. P naught is the pre-stress at transfer the short-term losses. First of all, analysis. The basic analysis and design of circumferential pre-stressing are provided for general understanding. Specific applications such as pipes, liquid storage, tanks, and ring beams. We are going to see about liquid storage and that ring beams, which is going to be placed over that. Analysis and transferring this FC is going to act. The area is the area of the longitudinal section of the slice. The permissible pre-stress is determined based on FC. Permissible pre-stress is based on within the allowable stress at the transfer. This is within the allowable stress. Analysis of service load. The tensile stress due to the internal pressure can be calculated from the tension T from equilibrium of half of the slice. We are not considering the full circle. We are considering half of the circle, which is T is equal to PR, where the radius of the mid surface of the cylinder. T is the radius. Okay. The resultant stress FC due to the effective pre-stress under the internal pre-stress is given that FC is equal to this equation minus PE by A plus PR by AT, where AT is the area of transformed longitudinal section of the slice. The value of FC should be compressive within the allowable stress at service loads. P is equal to PR and AT is greater than A and FC is always negative. Thus, the concrete will be under compression. To meet the safety standards, the factor of safety can be further introduced. Next, we can go with the design part. The internal pressure P and the radius R are the given variables. It is assumed that the pre-stressing steel alone carries the hoop tension due to internal pressure. That is P is equal to AP FPE equal to PR. This is the equation which is assumed that the pre-stressing steel alone carries the hoop tension due to internal pressure. There are 4 steps in the design process. We can see one by one. The calculating the area of the pre-stressing steel is done by this equation. AP is equal to P into R divided by FPE. The second step is to calculate the pre-stress and transfer from an estimate of the permissible initial stress. Initial stress is FP naught, where we are going to calculate the pre-stress and transfer from an estimate from this initial stress. P naught is equal to AP FP naught. And we have other two steps to calculate these circular pre-stressing. The third step is to calculate the thickness of the concrete shell. With this following equation, we can calculate the thickness of the concrete shell. The FC is allowable compression stress at transfer. The fourth and the final design step is to calculate the resultant stress FC at the service conditions. This is being given in the equation above here. First equation which we have gone under through, which is FC is equal to this equation. From this equation, we will find the last step, design step. Okay. By this, what and all we have find, we can equate it here and find the this FC. Okay. The value of FC should be within FC or the allowable stress at the service conditions. This must be within the limit conditions. Okay. Next, we can see about the pre-stressed concrete pipes. The pre-stressed concrete pipes are suitable when the internal pressure is within 0.5 to 2 Newton per mm square. These are the two pre-stressed concrete pipes, cylinder type and the non-cylindrical type. We are considering the cylinder pipe as a when we consider a cylinder type pipe, the steel core over which the concrete cast and pre-stress. A non-cylinder type is a pipe made up of pre-stressed concrete only, where we do not have the steel core, cylinder core, which is only a concrete one. In IS 784/2001 provides the guidelines of design pre-stressed concrete pipes with the internal diameter ranging up to 200 to 2500 mm. The minimum grade of the concrete should be here used is M40. The pipes are designed to withstand the combined effect of internal pressure and the external loads. The minimum grade, as I mentioned, it was M40 pipes. First, the core is cast either by centrifugal method or by vertical casting method. We can use both the methods. In the centrifugal method, the mold is subjected to springing till the concrete is compacted to a uniform thickness throughout the length of the pipe. If the vertical casting method is undergone, the concrete must be poured in the layer up to the specific height. After the adequate curing of the concrete, the wire are using first the longitudinal wires are pre-stressed. Subsequently, the circumferential pre-stressing is done by the wire wound around the core helical form. The wire is wound using the counterweight or a die. Finally, a coat of concrete or rich cement mortar is applied to the wire to prevent from corrosion, or we can use any other method to prevent it from the corrosion which is available in the from the wire. For cylindrical type pipes, first the steel cylinder is fabricated and tested. Then the concrete is cast around it. We are going with the cylindrical type pipes. Okay, with this, in this, we can see the analysis. The analysis and design of pre-stressed concrete pipes consider the stress due to the different actions. A horizontal layout of the pipe is considered in illustration. We can consider it horizontally, and we can find the steps. These are the steps and longitudinal direction of the following actions. First is the longitudinal pre-stressing. We consider as F by 1. Circumferential pre-stressing F2, and self-weight, transfer of handling, weight of the fluid, and weight of the soil above. These are the considerations we have to for the analysis. First of all, longitudinal pre-stressing. The longitudinal pre-stressing generates a uniform compression, where F1 is, we have seen that longitudinal pre-stressing is equal to PE by AC1. AC1 is the area of concrete in core, and PE is, we know that is effective pre-stress. And next, we are going with circumferential pre-stress. Due to Poisson's effect, the circumferential pre-stress generates longitudinal tensile stress, which is 0.284 into P by AC. The above expression estimates the Poisson's effect. This gives you the Poisson's effect. Next, we will consider about the self-weight. If the pipe is not continuously supported, then varying longitudinal stress generates due to the moment due to its self-weight. This is the equation for that, where Z is the section modulus about the centroidal axis. Next, transport and handling. These must be used when we transport the concrete pipe, cylindrical concrete pipe from one place to another. A varying longitudinal stress generates due to the movement of transport. Yeah, we can find many stresses generating while movement, so that we can consider a plus or minus M by Z. Next, the weight of fluid. After the transferring, we will see the concrete pipe in the action, where we will get the weight of fluid similar to the self-weight of movement due to the weight of fluid inside generates varying longitudinal stress. We can consider it's plus or minus. Then weight above the soil, which is going to be placed under the soil. So the soil weight also must be considered. The weight of the soil above for buried pipes is molded as an equivalent distributed load. The expressions of F by 6, which is similar to the fifth weight. By the longitudinal combined based on the following diagram. Stress are combined based on this diagram, where first of all we will applying, then we will transferring, and other liquid loads and the varying loads have been taken place. This is the section of the section profiles of the cross section, of the stress profiles of the cross section. Next, we see the stress circumferential direction due to the following actions, where we can see we saw about compression, circumferential pre-stressing, self-weight, weight of the liquid, and the soil above lower it. Then we have the live load and the internal pressure. As we see, the hoop stress are combined based on the following diagram. This is the core and this is the core, and we get the hoop stress by this. Okay. Next, we can see about the concrete storage tanks. In next video, but we can see now. 1 minute. We can see the design of dooms, ring beams. The ring beams are support in the buildings, tanks, and nuclear containment structures. We can design that also with the same analysis method, where we will find the dooms with r sin theta and things. Then I will conclude my presentation. The pre-stressing of concrete is observed in other types of structural elements such as bridge decks, shells, and flooded plates, offshore concrete gravity, structural hydraulic structures, payment of raft foundations. The analysis of special structure is based on advanced theory of structural analysis or the finite element method. After the analysis, the design of such structures follows the basic principles of pre-stressed concrete design. It is expected that in future, further innovations in structural form pre-stressing systems and construction technology will provide the application of pre-stressed concrete. Okay, thank you.